All right, guys. So this is our first foldable for chapter 10 that has theorems in it. And so we're going to talk about three theorems here. The measure of an inscribed angle theorem, the measure of an inscribed right angle theorem, and then the inscribed quadrilateral theorem. Okay, so we're first going to go over this one, the measure of an inscribed angle theorem. Okay, now the measure of an inscribed angle theorem tells us that the measure of an inscribed angle is 1/2 the measure of its intercepted arc. Okay, so in order to do this, we first have to know what an inscribed angle is. Okay, it is an angle, and it has to be inside the circle. Okay, the vertex is on the circle, meaning on the outside of the circle, and the sides are chords of the circle. Okay, so if I were to draw a picture of this, okay, the vertex is on the circle, and so it'd be like this and this. Okay, so this would be an inscribed angle. All right, so what this theorem tells us is this inscribed angle here. Okay, so D is an inscribed angle. Okay, if I go and I find its intercepted arc, which is right here. Okay, if I line these out, this is kind of the arc that's trapped, that this angle kind of traps in between it. So according to this diagram, angle D is 1/2 the measure of arc AB. Okay, or I could say that the measure of arc AB is going to be double the measure of angle D. Okay, some of you guys don't like all this, so let's just put some easy words or easy examples. So if angle D is, I don't know, what does that look like? A 45-degree angle? Then the measure of arc AB has to be double that. So it would be 90 degrees. All right, let's look at a couple examples. All right, so let's look at example 1 here. Okay, this is cut off a little bit. This should be 48. All right, we're going to look at the measure of this. This here is an inscribed angle. Okay, and with this angle, see how it meets on Q and T? That means that QT is its intercepted arc. Okay, so we know that the measure of QT, of arc QT, has to be double the measure of the inscribed angle. So the measure of QT is 100 degrees. All right, also, we have another inscribed angle, okay? Angle T is also an inscribed angle. Okay, and the intercepted arc here is 48 degrees. Okay, so if the arc is double the angle, that means the angle has to be half of the intercepted arc. So angle T then must be 24 degrees. Okay, and that's what this example asks for. All right, let's look at example 2 now. There's a whole lot going on, so I'm going to go and label this diagram. So it says the measure of ZYW, so ZYW. So this angle here is 80 degrees. And the measure of angle XWY right here is 35 degrees. We want to find the measure of WXZ, the measure of YZX, the measure of arc WZ, and the measure of arc XWY. That's a whole lot to have. All right, so rather than worrying about what we have to find, let's go ahead and just label what we know. Okay, this here that we know is 80 is an inscribed angle. Okay, and the intercepted arc would be right here. Okay, so the intercepted arc is always double the inscribed angle, so is 2 times angle Y, which is 80 degrees. So this is 160 degrees. And luckily for us, that was one of the things we wanted to find. Okay, now let's look at the other angle that we know, which is right here. Okay, that's 35 degrees. And so the measure of its intercepted arc, XY right here, I know that XY has to equal 2 times that measure, which is 35, which is 70 degrees. So this here is 70 degrees. All right, so let's talk about this. Here, if we have another inscribed angle right here at angle Z, and notice the intercepted arc for angle Z is right here as well. Okay, so I could say the angle XZY equals 1/2 of that measure of the intercepted arc, which is 70. So measure of angle XZY equals 35 degrees. So this is 35 degrees. All right, we still need WXZ. So WXZ is right here. And guys, it's another inscribed angle, and its intercepted arc is right here, which is 160. So I know that angle WXZ is going to be half of the intercepted angle, so half of 160, which is just 80 degrees. All right, so we're getting close here. The last thing we need is the measure of XWY. Okay, so we want to go in this order. So XWY would be all the way around to here. Okay, so it'd be the entire circle except not this arc right here. Okay, so measure of XWY, and that's the arc. Entire circle except this arc. Well, all the way around the circle, guys, is 360 degrees. So if I went it all the way around, it'd be 360 degrees. So I went all the way around, but not this arc. So I'm going to subtract the 70. So that would give me 290 degrees. That's the answer here. All right, so the measure of an inscribed right angle theorem. This is our second of the 3 theorems. If a right triangle is inscribed in the circle, which means that all vertices are on the circle, then the hypotenuse is the diameter of the circle. So if all 3 vertices are on the circle, then this has to be a hypotenuse. It also says if one side of an inscribed triangle is the diameter of the circle, then the triangle is a right triangle, and the opposite, the angle of the... Oh yeah, well that makes sense, guys. If this is a hypotenuse, then this has to be a right angle, and this has to be a right triangle. Okay, so this theorem tells us if we have an inscribed triangle, you have to know what an inscribed triangle is. AC is a hypotenuse because it's a diameter, which means B is a right angle. All right, let's look at example 3. Now we have an inscribed triangle here, and we know it's inscribed because all 3 vertices are on the circle. Okay, and notice that one of the sides of this triangle is a diameter. And if it's a diameter, that means this is a hypotenuse, which means angle C is a right angle. Well, angle C is 2x degrees, a right angle is 90, so 2x has to equal 90. Divide both sides by 2, you get x equals 45 degrees. All right, I want you to go ahead and try to do number 4 on your own, and then we'll go over it. All right, so we have this inscribed triangle. Once again, we know it's inscribed because all the vertices are on the triangle. And therefore, WY has to be a diameter because it contains the center. And if this is a diameter, that means this has to be a 90-degree angle. Or if this is a diameter, then it has to be the hypotenuse, which makes this a 90-degree angle. So 5x equals 90. If I reduce that, I get x equals 18. All right, so our last theorem is the inscribed quadrilateral theorem. Okay, so it says a quadrilateral can be inscribed of a circle if and only if its opposite angles are supplementary. So anytime you have a quadrilateral that's inscribed in a circle, okay, opposite angles, so I'm talking about F and D, or I'm talking about E and G, are supplementary, which means that angle E plus angle G add to 180. And also it means that angle F and angle D, X plus angle D add to 180. Always. All right, so let's look at example 5 here. Opposite angles, which would be D and F, and G and E, opposite angles are supplementary. So that means Z plus 80 has to equal 180. Subtract 80 from both sides, so Z has to equal 100. And it also means that Y plus 120 has to equal 180. So subtract 120 from both sides. My Y then has to be 60. All right, let's look at example 6 now. We're going to have to work a little harder for this one. All right, here I don't know anything about opposite angles, okay? But if I look at angle K, all right, if I'm looking at angle K, then this here, maybe if I can draw it, would be its intercepted arc, okay? And this here can be found by just taking 54 plus 130, which is what, 184, okay? And since angle K is an inscribed angle, angle K has to be half of that. Okay, so angle K, 1/2 times 184 is 92, so this is 92 degrees. Okay, now, from that, I know that opposite angles are supplementary, so 92 plus 4b equals 180. So minus 92, 88 equals 4b. I get b is 22. Let's do the same thing for angle J. Okay, if I look at angle J, it's right here, which means my intercepted arc would be this right here. Okay, and I can find the measure of that whole arc by taking 110 plus 130, which would be 240. Okay, so angle J is an inscribed angle, so it has to be half of the intercepted arc, so half of 240, which gives me 120. Okay, now I know that opposite angles, so if this is 120 here, I know opposite angles have to be supplementary, so 120 plus 3a equals 180, minus 120, minus 120, I get 3a equals 60. I divide both sides by 3, I get a is 20.